Alright guys, this is the second half of the review questions that I sent you. I will read the questions like we did before and show you how the math is done. So, first question. If you were running a 10 drop administration set at 100 drops a minute for 1 hour, which I'm just going to convert right to 60 minutes, how many liters of fluid would you have administered? So, we are looking, if you're using your volume over time formula, we are looking for your volume. Your volume is X. You are using 60 minutes. It's a 10 drop set. And you are going at 100 drops a minute. So you want to get the X by itself, so 10X equals 6,000. X equals 600. But now it's asking you for liters, and this is in milliliters. So you're going to take that, your decimal point, move over 3, 1, 2, 3. So you are going to administer 0.6 milliliters an hour. Question number 2. You need to give a burn patient 1,000 milliliters of lactated ringers every 2 hours. You're going to use a 20 drop set. What is your drip rate? So again, we're using your volume over time formula. You can do this one of 2 ways. You can simplify it before you get in, as you're looking for your hour rate. So that's half of this, and then you can just half this. So instead of doing 1,000 milliliters over 120 minutes, you can do 500 milliliters over 60 minutes, just to make your life a little easier, because it's just simplified. Halved, half one, you half the other, times your drip set. Let's simplify this. So 50 times I'm not going to do the long division for you. And this is one that doesn't have really great clean math. But that's going to be your answer. Alright. If you administered, this is number 3, if you administered 500 milliliters of saline over 1 hour, 60 minutes, at a rate of 500 drops a minute, what is your administration set? So again, your volume over time, you have administered 500 milliliters in 60 minutes. you are looking for X, and you have 500 here. So that means it's 500X over 60 equals 500 over 1. Cross multiply. 500X equals 30,000. You can get rid of some of your zeros on both sides. So it becomes 300 divided by 5. Goes in 6 times. So X, your drip rate, or your drop set, is 60. Question number 4. You have to administer 10 milligrams of Epi 1 to 1,000 to a 176-pound patient over 1 hour using a 20 drop set. You put this 10 milligrams into a 100 milliliter bag of normal saline. So what's your drip rate? So first things first, we don't care how much this patient weighs. 1 hour is 60 minutes. And you are going to administer all of this Epi, which you have put into this 100 milliliter bag, so that's your volume. So you have 100 volume over your time times your drip set. Hundred times 20 is 2,000 divided by 60. Make it a little easier. Again, this is one that doesn't have really pretty math, so it's 6 into 200. 6 goes into 23 times. 6 goes into 23 times. Decimal point goes up. This is 33.3. Repeating. Drops a minute. I have a small stroke. There we go. Alright. Question number 5. You were ordered to administer 0.5 milligrams of atropine to a patient. The atropine comes in 2 milligrams per milliliter. How many milliliters will you give? So you're looking for milliliters. So you have 2 milligrams. Your dose on hand is 2 milligrams in 1 ml. And you want to give your patient 0.5 milligrams. You're looking for your X. So cross multiply. 2X equals 0.5, which means that you're going to divide half by 2, which comes up to 2. A little quick review on your long division. How many times 2 goes into 0.5. We're going to bring this decimal up. 2 goes into 0, 0. 2 goes into 5 2 times. We're going to add a 0. 2 goes into 10 5 times. That's your math there. Remember, when you're dividing decimals, you don't have to move it over or anything. You just bring it straight up and act like it wasn't there in the first place. Question number 6. You have a patient who weighs 150 pounds. They have been resuscitated and have a BP of 60/40. You are going to establish a dopamine IV drip piggyback. You're going to use a 60 drop set. Milliliter, sorry. And want to give 5 mics per kilo per minute. You put 200 milligrams in a 250 bag. What is your flow rate? So first things first, we should recognize this mix, this dopamine mix by now. It's your 800 microgram per milliliter. This is your dose on hand. We're going to do a little rounding here because 150 pounds does not come out to a nice, easy kilogram, right? Your nice, easy kilogram is 154 pounds, which is 70 kilos. So let you know this ends up being 68 and change, but we're just going to use 68 for this. So to find out your dose on hand, you're going to use 68 times your desired dose, 68 times your 5 mics, which works out to 5 times 8 is 40. That's 5 times 6 is 30 plus 4 is 34. So this is your desired dose. Plug everything into your formula. 340, your desired dose. 800 is your dose on hand, times 60. Just not going to go through 340 times 60. 0, 0, 0, 0, 24, 18, 19, 20. Divided by 800. Simplify, get rid of those. So you have 204 divided by 8. 8 goes into 20 twice. That's 16. 4. 8 goes into 44 5 times. Drop your extra 0. 8 goes into 40 5 times. So your drip rate is 25.5 drops a minute. Question number 7. You have an IV containing 500 milliliters of fluid. You're using a 10 drop set. You are running at 20 drops a minute. What is the time to run the entire bag? So again, you're going back to using your volume over time. But now you're looking for your time. So fill in what you know. You have a 500 milliliter bag. You're looking for X. Your drip set is a 10 drop set. And your rate is 20. So this becomes 5,000. Multiply across over X equals 20 over 1. We'll cross multiply, so 5,000 equals 20x. And to get x by itself, and first you can simplify, and then how many times does 2 go into 500? Goes into 5 twice. Goes into 10 5 times. goes into 0 times. So it's going to take 250 minutes to run that entire bag out. Question number 8. You were ordered to give 10 micrograms per kilo per minute of dobutamine to a patient. The patient weighs 145 pounds. The dobutamine comes in a 12.5 milligram per milliliter package in 100 ml. You put one of these packages in a 250 milliliter bag. What is your drip rate if using a 60 drop set? So, first things first, right? We're going to convert pounds to kilos. Again, this is not a pretty math question, so we're going to do a little bit of rounding. So your patient here, right, you have 132 pounds, and then your next is 140 or 54, right? So this is your patient. It has 60 kilos to 70 kilos, right? If you actually divide 144 by 2.2 and do the long math for it, it comes out to just about 66 kilos. So we're going to use 66 kilos. And then you're going to find out what your desired dose is by multiplying this by the 10 mics per kilo that you have here. So your desired dose ends up being 660 mics a minute. Now you have to find out what your dose on hand is, right? So if you were putting one entire package that has a concentration of 12.5 milligrams per milliliter, and it's 100 milliliters, change color, you're going to do 100 times 12.5, which the super easy way to do it is to just move this decimal point over twice. So it becomes 1250 milligrams, and you're going to put that in a 250 milliliter milliliter bag. So you want this in micrograms though, right? So you have to move this decimal point over 3 more. So this becomes 5, 1, 2, 3 in 250 milliliters. Simplify. Now you're going to divide 125,000 by 25. Spoiler alert, comes out to 5. Or 5,000, sorry. Micrograms. So this is your dose on hand. So go back to putting it into your formula. You have your desired dose, just 660 over 5,000 times your 60 drop set. You can simplify here. And then as you multiply this out, and I'm not going to lie, I cheated and used a calculator, it comes to 7.92 drips a minute. Again, this one doesn't come out with nice, easy, pretty math, so cheated a little bit. Alright, question number 9. The patient is to be given 500 milliliters of saline over 4 hours. And this drop set is 20. What is your rate? So, first thing you're going to do is you're going to convert 4 hours into minutes. So that's 4 times 60. 240 minutes. Now you're going to plug in all your numbers into your volume over time formula. So here 500 divided by 240 times 20 over 1. Simplify this. So you have 50 times 20. 0, 0, 0, 10, right? So that ends up being 1,000 divided by 24. Goes into here 4 times. Right? It's going to end up being 96. 24 goes into 40 once. Run out of space. I'm going to cheat and use a calculator. Haha, because I can. Instead of doing my math, 16. Drop your 0 down. 24 goes into 166 times. $144. And this ends up being a repeating decimal. This times 6. So your answer is 41.66 drops a minute. Again, this one wasn't really pretty math, unfortunately. Last question, question number 10. A 198-pound patient is to be given 2 mics per kilogram per minute of dopamine. You have a 60 drop set. You put 200 milligrams in a 250 milliliter bag. What is your drip rate? So first things first, 198 kilos, 198 pounds is 90 kilograms. 90 times 2 is 180. This is your desired dose. And again, this should look familiar. Right, this is your standard dopamine. There's 800 mics per milliliter. Plug your formula. This is your dose on hand. Plug everything into your formula. 180 over 800 times 60 over 1. Simplify. 18 times 60 is 1080 divided by 80. And yes, I might have used a calculator, but this turns out to 13.5 drops a minute. So that's the second set of 10 questions. I hope this is helpful. If you have any other questions, please let me know.